Hello and welcome back. Today we're talking about LLM parallelization. All right, here we go. So previously, as a quick refresher, we talked about how our text corpus is broken down into segments. So for example, that's a segment. So all this trained data is split into segments. Each segment is given to the model's input. This is during training. In each segment, the model learns to predict every next word. And for example, for a 100 token segment, that means 100 training samples in one go each time. And that's crucial that all of that training happens in parallel. So it gets 100 trainings for a 100 token segment. And in reality, segments are actually much bigger. They're around the context size, which can be tens of thousands or even hundreds of thousands of tokens. And those context windows are growing as models get better. So that's how training is done. As you can see, we already have parallelization, and we're going to call it within segment parallelization, meaning that when you feed one segment to the LLM, it's not just training to predict the last word of that segment, it's training to predict every single word. So it's breaking up that segment into as many segments as they are words. So if it's 100 words, it's training as if it's just seen 100 different sentences of different lengths, and it's training 100 times in that one go. So that's within segment parallelization. In reality, it's tens of thousands of errors are calculated within one segment, and then a loss is calculated from that and backpropagated. So that's within segment parallelization. There we go. That's the first type. And the second type of parallelization is our usual batch processing or hardware parallelization. So here we've got our hardware. There can be lots and lots of different GPUs that we're training on. So there can be thousands of segments that are being processed within one batch. And then within each segment, there can be hundreds of thousands of samples being processed in parallel during the pass of a single segment. So we get best of both worlds. We get batch parallelization, which is based on hardware, and we get within segment parallelization, which is based on the inherent architecture of the GPU or the transformer. So we calculate all those errors, they get backpropagated. We use something called a mini batch gradient descent, and that way that loss that we calculate from the errors is backpropagated, and all the weights are updated once for all of this parallelization. Then we move on to the next step of our training. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.